right, let's talk about the two ways that you can approach this. Okay, the first way is to factor it. Okay, if you factor it, what you want to do is think in terms of rational power. So instead of a square root, we're looking at a power of 1/2. And so here, if we take our first two groups, or we have the two groups of factors in our numerator, what's the common factor you can remove from those two groups? A base of x squared plus 9, and you always take out the smallest power, which is which? The negative. What's left is going to have the same form, one group minus another group. And so let's see what happens when we take out a power of negative 1/2. So taking out, when you divide out exponents, you subtract their power. So minus a minus 1/2 is equivalent to adding the opposite. And so here we wind up taking out that entire set of factors, leaving an x squared. And in the second, we take a negative 1/2 out. So when you subtract a negative 1/2, you add the opposite, winding up with x squared plus 9. Okay, and that's all over x squared. So if we manipulate this expression, anything with a negative power gets moved down below. So the x squared plus 9 to the positive 1/2 is moved. And then we simplify what we have up top, distribute our negative. So we get a negative x squared and a negative 9. So we have x squared minus x squared, which cancels, minus 9. So we leave our answer negative 9 over x squared times an x squared plus 9 to the 1/2 as our solution. Okay. Are there any domain restrictions that we need to account for here that aren't shown in the simplified form? When we go back and look here, x can't be 0. We see that in the radical. We know that the expression x squared plus 9 can't be negative, and that's guaranteed because it's the sum of squares. You're not going to have a negative value there. So we wind up with our solution in that form. Okay, so that's one method. The second method that you could use on this is to treat it as a complex fraction. And if you're using this method, what you're going to do is convert everything into a radical form. So what we would get for this first expression, our x squared is positive, so it's in the numerator of a fraction. Our x squared plus 9 has a negative power, so we're going to move it into the denominator. X squared plus 9, just going to turn it into a radical. All over x squared plus 9, or I'm sorry, minus x squared plus 9, all over x squared. Okay, so if you're going to use this process, you're going to turn everything into a fraction. Again, you'll always see me represent those. And now we could either use the first or second method. Either one is fine. Say we use the first method here, which is just combine the numerator into a single complex fraction. So the LCD between these two fractions is just the root x squared plus 9. So we're going to take our first fraction's numerator, x squared, times any LCD factor missing from its denominator. It's not missing anything. Minus the next fraction's numerator, root x squared plus 9, times the missing LCD factor from its denominator. It's missing the entire thing. So if you took root x squared plus 9 and multiplied by another root x squared plus 9, that's equivalent to squaring it. And what's the square going to do to the radical? Cancels. So you're left with just an x squared plus 9. Therefore, if we simplify, distribute our negative, we get x squared minus x squared minus 9 all over root x squared plus 9. Okay, and now instead of dividing here, the x squareds cancel. And instead of dividing, we can multiply by the reciprocal. Again, part of why I wrote this in the fraction form is to make it easier to see that you do have to flip this fraction. The 1 and the x squared get moved. And so you wind up with your overall answer, negative 9 over x squared times the quantity, in this case, square root of x squared plus 9. Okay, no factors got canceled from the denominators. You see all the domain restrictions in the simplified form. And so either way, whichever way you approach it, is fine for this problem.